Okay, good morning.
Good morning, sir.
Yeah. So today we'll do the seventh program to arrange a series of 32-bit numbers in ascending or descending order. So this is again the sorting technique. So you know many different types of sorting techniques. So but here we go for applying the bubble sort. So we write the bubble sort logic in the assembly level program. Okay, and we sort them that sort the 32-bit numbers both in ascending as well as descending order. This is a program we'll see now. So I request all of you to make a note of this program, seventh write a program to arrange a series of 32-bit numbers in ascending or descending order. So logic, all of you know, only thing is how to write that logic in ALP, okay, is what is required. Because if I ask you now what is bubble sort logic, all of you can tell it, okay. So it's the same thing. Now the same logic we are going to implement using assembly code, that's all. So logic will not change. So logic remains the same. Only the language which you are using in order to implement that is different. Okay. Now let us go and understand the program first, and then we'll go for executing. Yeah, this is the program. So write a program to find the largest. Oh, sorry, not this one. Let's write the program to arrange a series of 32-bit numbers in ascending or descending order. So this is the program. Okay, let me start from here. So I've written two separate programs here, one for ascending order, another one for arranging the numbers in descending order. So this program is for arranging the numbers in the descending order, and this for arranging the numbers in the ascending order. Now here, see, this is what the 32-bit numbers I have taken. So in my code area, and where are these 32-bit numbers defined? They are defined inside the code area. So you can see this is my code area, and the name I have given to the code area is ascending. Okay, and all my 32-bit numbers, so 444, 111, 222, 333, and 222, they are residing in my code area, and I have declared the data area as well, and the name given to the memory location inside the data area is d value, and right now I'm initializing it to 0. So, so this is what I guess you people understood with the 32-bit numbers initialized in the code area, and one memory location reserved in the data area with the name d value, and the memory location in the code area I'm taking it as c value. So c value stands for code value, and this d value stands for the data value. So this part, is it clear? This is just only the data defining part. So this is what the data I have defined. Now I go for sorting these elements using the bubble sort logic. Is this part clear?
Yes, sir.
Next, we'll come back here. And one more thing which you already know is, so this code area is only read only. Okay. Now, if I want to swap these two, say big 444, I'm arranging in decreasing order, sorry, in ascending order. So 444 is bigger than 111. It requires a swap now. I need to swap 111 and 444. Now, is it possible for me to swap in the code area? In the code region, it is not possible because code region only can be read. So you cannot swap here. You cannot write here. Okay. So this 44 you have to read and you have to write to this memory location, and this 111 you have to read and write it to this memory location, and that cannot happen. Now, for but that purpose, what we are doing here, so you can just observe here. So I'm initializing R8 with the 4. So 4 is what? The number of elements. How many elements I have taken right now? 4 elements I've taken to short. 1, 2, 3, 4 elements. R8 is initialized with 4. And then R2 I'm initializing with the address of my code value, and R3 I'm initializing with the address of my data value. Okay. And then, so you look into this loop 0. So there are many loops here. So let us focus on first what loop 0 is doing. Say I'm reading the content of the memory location whose address is present in the register R2, that is R2 is right now pointing to the code value, reading the first number and then loading it into the register R1, and then I go for incrementing R2 by 4 bytes. And after that, after reading the first number to the register R1, what I'm doing, observe now, from R1, I'm storing it. Where I'm storing? Storing it to the address which is present inside the register R3. What is that you have inside the register R3? It is the address of the data value. So read the elements from the code area and store it into the data area. Okay, and then I go for this is post increment. Our R4 gets incremented by 4, and even R3 gets incremented by 4. And then I subtract R8 from 1 from the register R8 because one element I've copied now, and R8 is subtracted and made as 3. Go back, and again you're comparing B and E loop 0. Yes, this is 3 not equal to 0. Go back to the loop 0 and keep copying the elements from the code area to the data area. Hope people understood what this loop 0 is doing. So what loop 0 is basically doing is copying all the values which are defined inside the code area to the data area. Is that fine?
Yes, sir.
Is it okay with all? All of you are able to understand what loop 0 is doing? It is not doing any kind of sorting. So what it is basically doing is copying the elements which are there in the code area to the data area. Okay, next. Now, when R8 becomes 0, it stops and comes here. Next, what I'm doing, so I'm moving 3 to the register R5. So why 3 is a question now. See how many elements I have to sort. I have to sort 4 elements. Okay, the number of elements is 4. But in bubble sort logic, as per the bubble sort logic, if you have 4 elements, how many passes are required? So you have 2 for loops. I guess you people can remember from the C implementation what you have done for the bubble sort. There are 2 for loops. One is the outer for loop and another one is the inner for loop. What does the outer for loop track? It is the pass number. Yes or no?
Yes, sir.
So outer for loop says the number of passes. So if you have 4 elements, how many passes are required for you to sort all the elements? 3. 3 passes. Or in general, if you have n elements, so the number of passes required is n minus 1 passes. Now with that convention, so we have 4 elements here. We are loading the value 3, correct? No? Because the 4 minus 1 is 3. So that is the value which I'm loading into the register R5. Okay, number of passes. This is the number of passes. Next, and R7, I'm initializing it to 0. So what is this R7? R7 is a flag. I'm taking this R7 register as a flag register. Initially, I'm initializing it to 0. And whenever I'm going to change this to 1, so this R7, I'll either assign 0 or 1. So now I'm assigning 0. When I'm going to assign value 1 to the register R7, so whenever there is some swapping, okay, whenever, so I'm trying to arrange the elements either in ascending or descending order, whenever there the swap happens, okay, then what I'm going to do is I'm going to make this R7 as 1. So at any point of time, when if I look into the value of R7 and if it is 1, what does that convey to me? So there is the swapping has happened. So when any point of time when I look into the value of R7 and if it is 0, what does it mean? There is no swapping happened. Okay. So I need this. Later you'll understand why this R7 is taken as something like a flag and initially it is initialized to 0. Next. After initializing the number of passes to register R5 and after initializing the flag 0 in register R7, so now I'm taking the address of the D value to the register R1. Okay, so because I have all my elements, I'm nothing to do with the C value right now. My elements were there in the C value, code value, okay, code area. Now all those elements are now copied into the data area, so I don't have to do anything in the code value now. So all I need to do is in my data value right now. I'm taking the address of the data value to the register R1. Okay. Next, what I'm doing, so I'm loading the first element of my data value to the register R2. Okay, and then see after loading the first element to the register R2, R1 gets incremented by 4 bytes and it is pointing to what? 111. So right now what gets loaded into the register R2 is 444 and R1 is incremented by 4 bytes and it is pointing to the next number 111. Hope people are able to understand.
Yes, sir.
Okay. So it is pointing to 111. Next, in the next load statement, what gets loaded to the register R3 is 111. So I have 444 in the register R2 and 111 in the register R3. So next I go for comparing them. Comparing R2 and R3. So this is 444 and this is 111. So I am comparing. This is the condition. Branch and lesser than to loop 2. Okay. So now 444 lesser than 111. Condition is what? False. Condition is false. So branch and 444 lesser than 111 you are checking. So condition is false. Then don't go to loop. Don't skip these statements. This statements has to be performed. Okay. Now what you are doing? str r2 comma r1 comma hash. This is -4. Remember here this is -4. Okay. Now what is r1 right now? R1 is pointing to 111. R1 is pointing to this particular memory location. So observe my mouse movement also. R1 is pointing here. Now I need to what I have to do, the value which is available in R2, that is 444, when I need to write it, I need to write it to this memory location. Okay. So now right now R1 is pointing to this. Now this 444 which is in register R2, I copy it to this. So now this 111 gets replaced by 4444. I have 444 here also, 444 here also. Next what will happen after this operation, store operation is done. So R1 is decremented by 4 bytes. R1 was initially pointing here. Now R1 comes back and points to this particular memory location where 44 is present. Next what I do, the value which is available in R3, that is 111. So R3 was holding 111. Now this value which is there in R3, okay, R3, I'll write it to this memory location. So 111 comes to this. We have 444 and 111 exchanged. Hope you people are able to understand.
Yes, sir.
Okay. See, R1 will be pointing here. R1 will be pointing here. Since already R1 is pointing here, what I do, the value which is available in register R2, I write it to this memory location. Now this 111 completely get replaced by 444. Now, but there's still 111 which is there in the register R3 should be returned to this memory location. So that is the reason I'm taking R1 back by 4 bytes and I'm making it to point to the previous location here. Now R1 is pointing to this. In the next statement, so the 111 value which is available in the register R3, I go for writing it to this memory location. Now this gets completely replaced by 111. So we have 444 and 111 exchanged. We have 111 here and 444 here. Next what we do. So that is done. Now is there a swapping happened? Is the swapping happened now? Yes or no?
Yes, sir.
Now, what is that you got to do? You got to make R7 as 1. So now this R7, the moment you make it as 1, what does it indicate? It indicates that there is a swapping taken place. Okay, so this is just to make sure that whether the swapping has happened or not. Okay, so initially it was 0, R7 was initialized to 0. Since now the swapping has taken place, so R7 is made as 1. Okay, now where is R1 pointing? So R1 initially it was pointing here, then we decremented it for the purpose of swapping. Now R1 is pointing to this. Now what is that we got to do? Again I got to restore the R1 and make it to point to this memory location. So add R1 comma 4 I'm doing. R1 is pointing here. Now if I add 4, R1 comes and points to this 111 where it was originally pointing. Okay, I'm restoring the R1 pointer by adding 4 and making it to point to this particular memory location. Okay, we will debug it. You'll understand much more clear. So, but before going to the debugging, I need to give the complete insight into the program. Okay, next. Okay, done. After this statement, the R1 is restored. We come here because so we are in the pass 1 now. So 3 passes you got to do. So in that we are doing the first pass. So first pass we have finished comparing the first comparison. Now what I am doing, so again I go for decrementing the value of R5 by 1. It becomes 2 because 2 more comparisons I got to do. What are those 2 comparisons? Still I got to compare this. So now it is exchanged. 111 is here, 444 is here. So this 444 should be compared with 333, and next again this and this should be compared. 2 more comparisons are required. So out of 3 comparisons, 1 comparison is done. So still we got to go with 2 comparisons. I'm subtracting the value of R5 by 1. So now R5 becomes 2. Now again branch are not equal. Okay. So compare your R5, that is 2 with 0. Yes, not equal. Now go back to the loop. Come back to the loop here. Okay. So there is something called as loop 0, and we have loop, and then we have loop 2 as well, and start also. Okay, start 1 I have given. So don't confuse. So where we are looping back to the loop. Now I come here. Now where R1 is pointing, because we have already restored it and made to point to this particular memory location. So what do you have here? Now it is not 111, it is 444 because these two are already exchanged. So here you have 444. Now in this 444, if you want, I can write here. Let me write. So we have 44. This is updated one which I'm writing now, and your 111 is stored here. And we have R4, R1 pointing here. Next, what I'm doing, so I'm loading this 444 to the register R2. R2 gets 444, and R1 is incremented by 4 bytes, and R1 is pointing to this 333 right now. In the next statement, what gets loaded to R3 is 333. And now you're comparing 444 with 333. So this 444 and this 333, we are comparing. Again, branch and lesser than to loop 2. So 444 is not lesser than. Okay, now the swapping is required. So we come here. What we do, we store the value which is available in R2 to this memory location. Okay, so this R1 is pointing here. Now this 333 should be overwritten by 444. Let me write here 444. And this 333, which is in the register R3, should be loaded to this memory location. See, I've already decremented. So after loading this 444 here, R1 is decremented by 4 bytes and R1 is pointing to this memory location. Next, what I do, the value which is available in the register R3, I write it to this. In R3, we have 333. It comes and sits here. Okay, so 333 is written there. And next, again, there is a swap taken. So I got to make R1 as R7 as it was already 1. Now still again, since there is every time the swap happens, this R1 should be made as 1. I'm assigning the same 1 value to the register R7. Next, what I'm doing, add R1 comma 4, because I got to restore my R1. So now it is pointing here. I don't want it to point here. I want it to point to this 444. Okay. Now again R1 is made to point to this 444. And now we come here, decrement R5 by 1 more. It was 2. 2 minus 1 is 1. Again I'm comparing 1 with 0. They are not equal. Loop back. Come here and then load what? The point. What gets loaded to the register R2 now? Again 4, because R1 is pointing here. Again 4 gets loaded. And then after loaded, 444 gets loaded into register R2. R1 is incremented by 4 more bytes, and it is pointing to this 222. So next to register R3, what gets loaded is 222. In R2, I have 444. In R3, I have 22 now. I'm comparing 44 with 222. Branch and lesser than to loop 2. Again, the condition is false. 444 is not less than 222. So swap is required. So we are swapping what and what? This 222 and 444. Now what happens? So here we get 444. Then, so after that, this gets replaced by 222. So now we are done, and there is a swapping happened. So where is this R1 pointing? R1 is pointing to this 222 because this is the most recent write operation that is done, and R1 is pointing to this. We make R7 as 1 and we restore R1 back to this. Now R1 is pointing to this. Now again we come here, decrement the value of R5 by 1. R5 value previously it was 1. 1 minus 1 is 0. Now compare 0 with 0. Branch or not if condition is false. Okay, condition is false. Now it will not go to the loop. Instead it comes here. Now you're comparing R7 with 0. Okay. Now what is R7 now? R7 is 1. That means the swap has happened. Swapping have happened. 1, you're comparing with 0. So not equal again. Yes, they are not equal. So the only first pass we have completed till now. Still we got to go with 2 more passes. So branch and not equal to start 1. Come back and initialize R5 again with 3. So this is the end of the pass 1. So you can see what will happen if you're arranging the elements in the ascending order. At the end of the pass 1, the biggest element goes to its proper position. Yes or no?
Yes, sir.
See, that is what you're seeing. See, 444 is placed in its proper position right now. And now, so you're comparing R7. So you're checking whether R7 value is 0. If R7 is 0, what does it mean? There is no swapping happened. All the elements are there in the proper order. Okay. So now since R7 is 1, so branch and not equal to start. Where it will come? It will come to the start 1. And again loading R5 register with the 3. Okay. So, and then initializing again this R7 to 0. We're initializing it back to 0. Now again load D value to R1. So R1 again we are making it to point to this memory location, and then loading R2 with 111. loading R3 with 333, and then comparing 111 with 333. Yes, 111 is lesser than 333. Now loop to loop 2. So branch to loop 2. That means execution of these statements is skipped because 111 is already lesser than 333. It comes here. Now what we are doing, we're just subtracting the value of R5 by 1 and then comparing R5 with 0. So it is 2 and 0 not equal, go back to the loop again. Okay, now what is happening, so now 333 gets loaded into the register R2, and then 222 gets loaded into the register R2 R3. Now comparing 333 with 222, so 333 lesser than 222, condition is false, we require a swap. So these two gets exchanged. 222 comes here and then 333 comes here. So first it writes 333 here and then 222 here. Okay, and then we restore. We make R7 as 1 and we add the 4 bytes to the register R1 and we restore it back to this position. So we have R1 pointing to this. In the next iteration, what happens? R5 is decremented by 1 more. It becomes 1. 1 compared with 0. Now again go back to the loop. Now what goes to register R2 is 333 and what goes to register R3 is 444. 333 compared with 444. So what happens here? So this 333 is lesser than 444. Okay, so you got to mentally execute along with me, otherwise you'll not understand anything. Okay, so 333 is lesser than 444, condition is true. Now where it will come? To loop 2. It will skip the execution of these statements and it will come here because 333 is already lesser than 444. Now compare, subtract one more from R5, it becomes 0. 0 compared with 0, branch and not equal to loop. This is false and it comes here and it is comparing R7 with 0. Okay, it is comparing R7 with 0. R7 value is 1 because there were a few swapping happened here and R7 is 1. 1 compared with 0, condition is false. So condition is true, not equal to is true. Go back to the start one again. Now R5 again initialized with 0. Observe now carefully. So R5 again initialized with 0. See, all these elements are already in the shorted form. R5 is again initialized with 3. R7 is initialized with 0. And R1 I'm making it to point to here. Okay, and then I load R1 with 2, R2 with 111, R3 with 222. I'm comparing. So 111 is already less than 222. You don't require the swapping. That means R7 is not made as 1. R7 is still 0. Then come here, decrement one more, and then again compare, go back to the loop. Now 222 gets loaded to R2 and 333 gets loaded to the register R3. Again compare. Yes, 222 is already lesser than 333. So you don't have to swap. So it comes here. It skips all these things and comes here. And again, what is the status of R7? See, here you can understand the importance of R7. What is the status of R7 now? What is the status of register
0.
R7?
0.
0. It's still 0. Now, and again decrement one more from R5. It becomes 1. Okay. So now you're comparing 33 with 444. Okay. Come here again 333 and 444. So 333 is lesser than the 444. Branch to loop. Again you skip this. Again still the status of R7 is 0 itself. And then we come here. R1 is decremented by 1 more. R5 is decremented by 1 more. It becomes 0 now. So 0 compared with 0. So branch and not equal. The condition is false. It comes here. Now you're comparing R7, which is 0 with 0. 0 and 0. Branch and not equal to start. Will it go to the start one now? No, it will not go because R7 value is 0. So it's understood. When R7 is 0, when you're doing this comparison, what does it mean? All the elements are shorted. All the elements are shorted, and then so what we do, so we come out of this start one and we say back be back and we stop the process. I guess you people understood it.
Yes, sir.
So the understanding the significance of R7 is very important here. Okay. Okay. So when R7, when you go with one complete iteration, sorry, one complete comparison of all the elements from the first element till the last element, if the R7 is not changing from 0 to 1, what does it mean? So all the elements are in the proper format or in the shorted format. Okay. So now we'll go for executing this program and we will also debug there. It'll get more clarity. So I'm copying this. Yeah, it's there already. It's the same program for ascending. Let me check the condition what I've written here. Okay. BGT I've written branch on greater than. Instead, I got to make it as BLT, branch on less than. Okay. Same program, even the data is also same. You can see here. 4441113332222 is the data taken. Okay, it's the same program which I explained now, copied here. Yeah, let us go for executing this. Okay, let me uncomment this compare also, because it will be easy for explaining, and you will also understand what's happening. Okay, let me push this comment line towards right. So otherwise it looks little odd. Now it's fine. Okay, let me save this. So I'm translating. So building. See, program 7.axf file is generated. This is the ARM executable file. I'm debugging now. Okay. So memory windows, I have already 2 memory windows. Let me make it a little bigger. Okay. This is one memory window. This is my another memory window. Okay. Let us start. So since I've taken 4 elements, so we're initializing R8 with 4, because I need to first copy all my code values, the values which are there in my code area to the data area. See, I'm loading R8 with 4. Okay. And then even I don't know where exactly inside the code area my data values are present. So now I'll come to know LDR R2 comma is equal to C value. See, so my data values within the code area, they are present at the address 6C. Let me come here. So this is the address of the data area. Let me retain this memory window as it is. Now I'll come to the another memory window. My address is right now 6C. So if I press 6C, see all my data values, so which are defined here in the code area, are starting from the memory address 0000006C. Correct? No, this is 444111333 and 222. Hope people are able to see these data values which are there in the memory starting from the address 6C.
Yes, sir.
Okay.
Yes,
So
sir.
now, so I'm loading the address of the data value to the register R3. All of you know R3 will get the address 4 followed by 7 zeros. So it got the address 4 followed by 7 zeros that I have in the another memory window. 4 followed by 7 zeros. Now, so just copying. So now what I'm doing, R2 is pointing to this memory location. So this 444. Now this 444 where it gets loaded to the register R1. So it comes to the register R1. So from R1, what I'm doing, I'm storing it into this memory location. R3 is holding the address of what? The data value right now, that is 444. Now this 444, which is copied to the register R1, now gets stored to this memory location. I'll press F11, you can see now. See, it got stored here. And then subtracting 1 from, and R3 and R4 both are incremented. So R2 is where it is pointing. R2 is pointing to the next memory location, that is 111, and even we have R3 pointing to the next memory location here in the data area. Okay, now subtracting 1 from the register R8, because still I got to copy three more elements. So comparing this 3 with 0, 3 is not equal to 0, true. Now we are jumping back to the loop 0. Now loading R1 register with the next value from the code value. Now what gets loaded to register R1 is 111. So register R1 gets the value 11 now. See, R1 got the value 111, and this value which is there in register R1, we are storing it back to this memory location where R3 is pointing. R3 is pointing to the next memory location in the data area. Now 111 gets copied here. So I press F11. See, 111 which was there in the code area is copied to the data area also. Now subtract one more from R8. Compare, this is 2 now. 2 with 0. Yes, they are not same. Again loop back to 0. Now load R1 with the next value in the code area, that is 333. R1 gets 333 now, and then this 333 which is there in register R1, we are storing it to this memory location. So we have it in this memory location now. Now subtract one more from R8, it becomes 1. 1 is compared with 0. No, still we got to copy one more element. So by Bn is true. Now go back to the loop 0. Now what gets loaded into the register R1 right now is 222. 222 gets loaded to register R1. See, 222 is loaded into the register R1. So now again store this 222 which is in register R1 to the memory location here. This memory location which is there in the data area. You can see 222. So now all my elements from the code area is copied to the data area. Now I go for subtracting one more from R8. It becomes 0 now. You're comparing 0 with 0 and 0 equal to 0. And what are the condition you're checking? Not equal to. Now the condition is false. It will come out of the loop 0. So we are out of the loop 0 now. Now what you are doing? We're initializing R5 with the value 3. Why? Because 3 passes are required. So I'm initializing because 4 elements I have, 3 passes required. In case if you are taking 6 elements, the value that you should move to the register R5 is 5. Please do remember all these things. Okay, I'm initializing R5 with 3, and next initializing R7 with 0. You know the significance of R7 now. We are taking it as a flag register. It is not a flag. It is basically a register which is going to store a 32-bit 0 value and 32-bit 1 value. Okay, now 0, and now I'm taking the address of D value to the register R1 again. Okay, now I'm loading the first value which is there in my data area, that is 444, to the register R2. So R2 got 444, you can observe here, and to R2 is loaded with 444, and R1 is incremented by 4 bytes, and we have R1 pointing to this memory location. You can just observe R1 is 4 followed by 6 zeros and a 4. What does it mean? It is pointing to this right now. Post increment, it is increment after loading. R1 is post incremented by 4 bytes. Now what gets loaded to register R3 is 111. So R3 is loaded with 111. Now we go for comparing. So I just drag the cursor on the register R3. It is showing it has 444 and R3 has 111. So comparing 444 with 111. So branch on lesser than. Okay. Branch on lesser than. So 444 lesser than 111 is the condition. Now the condition is false. It will not jump to the loop 2. Instead, it goes for swapping. Okay. Now what we are doing? We are storing this 111. Okay. Sorry, this R2 value that is 444 to this memory location where R1 is pointing. Where R1 is pointing now, it is pointing to this memory location. Now this 111, it will get replaced by 44 right now. I'm pressing F11 now. You can see that 111 is replaced by 444. Okay, and then where is R1 pointing? Just observe the R1 register now. It is 40007 zeros. Earlier it was pointing here. After this is written, see, since I've taken the -4 value, R1 is decremented by 4 bytes and it is made to point back to the previous memory location. Now it is pointing to this. Now what happens? The value which is available in the register R3, that is 111, so is stored to this memory location. So I'm pressing F11. You can see now. Now we have 444 and 111 exchanged. 111 exchange. Since the exchange has happened, so we got to make R7 register as 1. Whenever the exchange happens, make R7 as 1. So R7 is 1. Now restore back the R1. So R1 is pointing right now here. Now I want to make R1 point to this particular memory location where it was originally pointing. Add 4 more bytes. So it was 4 followed by 7 zeros. Now if you add 4 bytes, it becomes 4 followed by 6 zeros and a 4, and it is pointing to this memory location. Now it is pointing to this memory location. Okay. Now we are done with one comparison. So we got to decrement R5 by 1. So decrement R5 by 1. So it is 2 because 2 more comparisons are required. Now compare 2 with 0, not equal, condition is true. Go back to the loop where it comes here. Again, loading R1 register, sorry, R2 register with 444. R2 gets 444 because R1 is pointing here. So R2 got 444. Now R3 gets the value 333. 333. Comparing 444 and 333. Again, the condition is false. Don't jam. So go for swapping. Now yes, see these two get swapped right now. These two get swapped. 333 and 444, they get swapped. See 444 and 333. So people are able to understand.
Yes, sir.
Are you able to track the logic how it is working along with me?
Yes, sir. Yes,
See,
sir.
it is only possible if you focus on your the screen what I've shared, and you should simultaneously listen to what I'm saying. So if you lose the track, if you're not following what I'm saying, okay, and if you miss something, then it is not possible for you to understand. So your focus should be completely on the screen that is shared, and your mind should be constantly listening what I'm saying, and it should try to react according to that. So this is what is called as mental execution of the program. So it's not like you should always go for running the program on the CPU and see the output. So when a program is given, it is also possible for you to mentally execute the program. Just look into the program, go with the sequence, and try to understand how the computations are getting done. Okay, this is what is the mental execution, or and the mental execution of the program is very much essential for tracking and understanding the logic behind it. Okay. Now, since the swap has taken place, R7 we are making it as 1, and we are restoring the R1 back. So where R1 is pointing to, it is pointing to 333. I need to restore it back and make it to point to this 444. Next, subtract one more. Now it becomes 1. Okay, compare 1 with 0, not equal. Again, go back to the loop. Now what gets loaded to R4? R2 is now again 444 gets loaded, and then to R3 we have 222 get loading. See 222. Comparing 444 and 222, again the condition is false. So go for swapping. Now you can see 222 gets and 444 they exchange. See 222. Again, so since the swap has taken, make R7 as 1 and restore the pointer back to this position. So here, now R1 is pointing here, now make it to point to this. Now subtract one more from R5. So it was 1, now 1 minus 1, 0 it becomes. 0 compared with 0. So branch are not equal. 0 equal to 0, but we are saying not equal. Branch are not equal. The condition is false. What happens? It comes here. And we are comparing R7 with 0. Is R7 0? No, R7 is not 0. R7 is 1. Okay. Now, so branch are not equal to start 1. So we are done with the first pass. We are going for the second pass now. So at the end of the first pass, what happened? The biggest element has taken its correct position. Okay. The biggest element in this list of array was 444, and now it has taken its correct position. Now we are going back to the start one to start with the second pass. Again R5 initializing with 3, R7 reinitializing it to 0, and D value R1 we are making again to point back to this location 111, and then observe now. R2 gets loaded with 111, R3 gets loaded with 333. So 111 you are comparing with 333. 111 is compared with 333. and the condition is less than. Yes, 111 is less than 333. Condition is true. Now what it will do? It will skip the execution of these statements. So the statement from here till here is skipped and it directly comes to subtract. So if I press F11 now, see we are in the subtract. That means execution of these statements is skipped. And subtract 1 from R5, it becomes 2. Compare 2 with 0 and again go back to the loop. See, so 111 and 333, they remained as it is. Next, what gets loaded to R2 is 333. So 333 and to R3 it is 222. Now you're comparing 333 lesser than 222. Condition is false. Now go for swapping. So you can see now this 333 and 222 they will get swapped. See, they got swapped. Again, so since there is a swapping happening, so R7 should be made as 1. Yeah, R7 is made as 1 and restore the pointer back. So decrement one more, it becomes 1. Compare 1 with 0, not equal, go back. Now you're comparing, so loading R2 with 333 and R3 with 444. So compare 333 is lesser than 444, true, no swapping, skip, and decrement R5 by 1, it becomes 0. 0 compared with 0, what does it mean? True, the condition is false. Now compare 0 with 7 again. Okay, so in R7 we have 1, 1 is compared with 0, again it goes back to the start. Now in this last pass, now R3 is, R5 is initialized with 3, see now, R7 is 0 and D value is R1 is initialized back here to this memory location. Now load R2 with 111, R3 with 222, comparing. So 111 is lesser than 222. So now we are not swapping. We're not swapping. So R0 still remains 0 itself and it comes here. It comes here. So R5 is subtracted. Next. Compare 222 with 333. Again, no swapping required. Now again compare 333 with 444. No swapping required. Okay. Now R5 is 0. Come back. So it will not go to the loop now. It will come to compare. What is R7 now? See, R7 is 0. What does it mean? So there is no swapping taken. So I went through one complete pass and I compared from beginning till the end. There is no swapping. What does it mean? The elements are already in the proper format. So now I understood. So by looking into the value of R7, that all the elements are in the shorted format. And now I go for terminating the program. So be back. Hope you understood.
Yes, sir.
Okay. So this is, so I debugged the program. So now let us go for executing this program at once. Okay. Let me stop debugging. And again I'll debug. Okay. Now I just go to this and click on the run. Okay. So here you can see all the, let me go to the other memory. These are my elements, unsorted array. And this is my data area. Here you'll get the sorted array. Okay, I'm pressing F5. That's all. F5. I pressed F5. See, my program got executed at once, and all the elements in my unsorted array, which is here, is in the sorted form in my data area. Is that clear?
Yes, sir.
Okay. Now, for this is for the ascending order, and for the descending order. So same program. So what is the condition we were checking here? So branch and lesser than to loop 2. Okay. So if the data which is available in the register R2 is lesser than the data which is available in the register R3, so skip this we were saying now. So when you're arranging in the descending order, now this condition, instead of branch and less than, it should be branch and greater than, BGT. Okay. If the value which is available in the register R2 is bigger than or greater than the value which is available in the register R3, which is the second element, so then you got to skip this. Okay, people are following?
Yes, sir.
So this is the only change. Okay, so BLT should be changed to BGT for getting the sorted elements in decreasing order or descending order. And in your observation copy, you got to make two separate programs. Okay, don't write one program and write a comment line saying for descending order instead of BLT, write it as BGT. No, no, you have to write two separate programs in your observation copy. Now let us go for executing this. I've changed from BLT to BGT. I got to again translate my program. So build my program. Now debug. So I don't go for step-by-step debugging here. Let me execute it once. So I'll go to the memory. Okay. So these are my data in the memory, which is an unsorted array. Okay. Now I come here. I'll go for F5, pressing F5. See, my elements are now sorted in the decreasing order. So 444, 333, 222, 111. So hope people are able to understand the program.
Yes, sir.
Okay. Okay. Let us stop here for today.